We have Paul Zuradzki, who is a lead senior data science engineer at Turquoise Health, where he works to increase price transparency and make simpler upfront transactions in US healthcare. We've gotten to have a couple of great conversations about testing in the current development environment this week, and I'm very excited for his talk about how to test SQL. Thank you.
Thank you. Hello, PyCon. There will be Python, I promise. There's a QR code for the slides here. I'll have one up at the end. If you take photos throughout or forget, it's okay, don't worry. But photos are welcome too. Cool. So we already went through the intro, but a little bit about the perspective I'm coming at this with is that I've worked in the back end of a Django application. I've been in data roles, doing raw SQL stuff, ORM stuff. So it's been kind of interesting seeing how different teams handle testing discipline and approaches. And here's a little bit about our agenda. And first, let's start with why testing SQL is tricky. So first, quick show of hands. Who here uses SQL regularly? OK, that makes sense. Who here uses PyTest? OK, maybe 3/4 of the room. Yeah. We're going to pause for 30 seconds, turn to the person next to you, and discuss why testing SQL is tricky. Can I get a volunteer to list one thing that you guys talked about? What was brought up was that you need to reproduce the state of a database for your test, and that can be tricky. Anything else come up in folks' conversations here? Yep, having to create a dummy database, you usually have a production database, and there's work involved when you need to kind of mirror stuff, right? Anything else come up? Stored procedures. Yeah, SQL is declarative. You don't have a step-through debugger and that kind of thing, right? Anything else? User input is unreliable. That also came up. Cool. Yeah. So I don't really need to spend too much time on this slide, but yeah, a couple other things. Some of these things y'all brought up already, but we also have just different SQL dialects floating around, right? Maybe your prod stuff's on Postgres. What do you do locally then? Do you run Postgres? Do you use a SQLite sort of fake implementation? Do you do some in-memory Python stuff? Are you actually testing what you meant to test? And some of it is just experience. I'm hoping there are some business analysts, analytics folks in the room too that are coming into Python too, and hopefully get a little taste of Python and things that can help some of your SQL work. Now, when you don't have tests, and this is totally valid to do, you should do manual verification as well. But this is kind of the typical testing workflow. And this is what you should probably want to do at minimum, but it's not super reproducible, right? If I get a 1,000-line SQL pull request and I don't really know the domain, what's a little tricky with this approach is there's a lot of implicit knowledge there. When I was first writing this talk, I thought of how would you teach testing in general, and would you talk about unit tests, integration tests? How many folks are familiar with those terms? Okay, most folks. Okay, cool. Real quick, if for the just to carry folks along, unit tests, think of testing a unit. It might be a function, a class, however you want to define your unit. And I like to describe integration tests as your the wiring between components, right? Sometimes you get into the semantic debate of when you're testing database stuff, is it it's not a unit test, it's an integration test because it touches the database. We won't care too much about words in that case, but I think it's easier to think of it as just what are we trying to test here, and then where do we want to run it? So that's kind of how this talk's going to be structured. Now the example here, and I can try to zoom in a little bit, but the code's not super important. We're going to work with a simple, these techniques are going to carry over to less trivial examples, but I need to make it a little slide friendly. So we're going to work with this orders table. We've got a region, some item that we can sell, and some dollar amount. Let's call it a sales amount. So that's the table we're working with. And then also on the Python side, I'm going to be showing some test code. So we're going to be using Python for running our tests. And I'm going to be following this structure here. Who here is familiar with AAA? Cool. A few hands. So a common way to write your tests or organize it is in this arrange, act, assert pattern. So usually at the top of your test, you do your setup. That would be your arrange step. In the middle, you do your act. You do the thing you want to do, and you might capture the result. And then you've got your assertion step when you do your assert. Sometimes if you get a test where you're kind of commingling a lot of this, like you're doing some setup, asserting some stuff, more setup here or whatever, if you can avoid that, that sometimes helps for readability. You can't always. Sometimes you do want to assert something before something else happens, but this is a nice template. You might hear it called given, when, then. Now the query we're going to kind of like work with is simple, but like you can do this with more complicated. The techniques will show with more complicated queries here, but I guess just looking at this, so we're selecting from an orders table. What are some behaviors that we hope to hold true after running this query? Make sure the table hasn't changed. I've spent more time with the query, so I can also help walk us through it, obviously. But we're doing some aggregation. We've got a filter going on. Is the order important? It's not like, and depending on your context, not every behavior needs to be tested. So just teasing out what's the thing you care about is going to be important, and then. Some of the techniques we use are going to use common table expressions. How many folks are familiar with CTE? Okay, it looks like 2/3 of the room. We won't have time to over-explain it, but if you need to like look it up later, common table expression, I like to think of it as sort of an alternative to a subquery. In the bottom where we're querying from the orders, I should scroll down. Or no, here we're in the top part, we're querying from orders. We have a named reference grouped, and then later down, we can use that named reference, and that table is not persistent. And there's going to be a few tricks that take advantage of that. So let's start with just testing transformation logic. Introducing a few terms really quick. This could be like just a general testing talk in disguise, like where you just happen to be talking about SQL, but one term is this notion of a test double. So I consider that kind of the broadest notion, any stand-in for like a dependency. So you're using Postgres, but maybe locally you want to use SQLite or some in-memory thing. So there's various words for these substitution strategies. A test fake, I would think of that as let's say you have a class that does some stuff with Postgres, and you create another class that implements the same interface. So then when you try to test it, you can just swap in that fake class, for example, right? But it takes like some design skill to kind of think ahead of like, oh, I need this like swappable implementation. If your code is not testable, a test fake might not be like an option for you. And then you've got mocking. Early on with like AI-assisted code, did anyone notice like, I mean, maybe even today, a lot of mocks in test code, even in Python with AI-generated code? Okay, one hand, a few hands. The one thing that I thought was funny was like when you use mocking is you basically just test stuff around the SQL, but you don't actually test the SQL. So you might like stub in some fake values, verify that .execute was called, and then it's like, oh, the test passes, but you didn't really test if you have a lot of business logic in the SQL, that's important to test separately too. And we covered CT, so that is a little bit of vocabulary for today. Now we're going to use a few helpers. How many people are familiar with the DB API? You've probably seen it before if you're working with Python and SQL. Okay, a few hands up. So basically the idea is this. If you implement certain methods, then you're compliant with this API. So in this run SQL helper, we take a connection. I never said what kind of connection it is. It could be SQLite, it could be Postgres, it could be something else. They do have a few individualistic kind of quirks to each of their API. But if you comply with PEP 249, I can create a cursor, do con.cursor, cur.execute SQL, return some Python objects with a list of results. But the trick here is that as long as you follow that interface, or in this case, for a testing helper, we do something that uses a connection that's swappable. You can kind of take advantage of these swappable implementations. Another thing we're going to come across in some of the examples here is the notion of fixtures. How many folks are familiar with PyTest fixtures? Okay, it looks like 3/4 of the room. Real quick for the folks that didn't raise your hand or for the recording, the way I like to describe it is just as a sort of resource you need to reuse, so often like a connection, and then often there might be some notion of like setup and teardown. I like to introduce it usually using the unit test example because it's a little bit more explicit, where before your test you do some setup thing like initialize a connection, maybe you do some other setup like creating tables or something else, and then after the test you do something to tear it down. So in this case we don't want a bunch of open connections. The PyTest, in PyTest land, the setup is basically everything before the yield statement, and the teardown is everything after. And the yield statement itself on the left is kind of the resource we're trying to use. I found that kind of confusing at first. It's nice like concise syntax, but just something you might bump into as you're trying to use Python for testing SQL. So. In this case, one way to test like transformation, so the earlier query we had is just using an in-memory or local SQLite file. So in this case, what we're going to do is we're going to have our Python test pass in a SQLite connection. I'm going to hand wave what insert seed data. Just imagine a bunch of insert values into statements in there. And we've got our run SQL helper, and maybe we load our SQL from a file rather than like from importing a string from some other module or that kind of thing. And we get the results, and we have some expected results, the shape that we expect it to take. And that's one way you can run a test. And then what's nice about this is, like I said earlier, is you could swap in DuckDB connection if you want to try that as well. Anything stand out of like kind of weak points with this test, or what does it test, what does it not test? We'll get to it later. Another cool trick, I discovered this actually while researching the talk. How many folks have used DuckDB for testing SQL? A couple hands, fewer. So what's kind of wild here is you can write like SQL as your string, right? In the lower part, select stuff from orders. But where is orders? And where is like our database connection? And what's happening here is we're initializing a data frame of orders. And basically, you're running a query against a data frame. This is pretty cool, but you're kind of like trusting DuckDB's implementation there too. Like maybe you're running SQL and Postgres. Like, is this getting what you want? But I thought that's cool to be aware of. Now earlier I hinted on like what's the weakness of that. The SQLite test. Let's say you've got like a Postgres database that uses some, there's some parts of the dialect that like you can't just copy paste that SQL and run it in SQLite. So that's one issue. Transpolation's a problem. There might be features in Postgres that you're using, like some extension, like a GIS extension that's not available in SQLite. So now your query that relies on that won't run, even if you transpiled it to SQLite. But this is a tool worth knowing about. I don't like teaching specific tools, but today this is a really cool one that I've enjoyed. And the trick is that it lets you transpile dialects. So the main difference here is that the SQL we're reading, and pardon the zoom, I'm going to try there we go. Basically, you pass in your source, so Postgres dialect, and then the destination source that you want. We want to rewrite this SQL to SQLite flavored SQL, and then I'm going to run using that SQL against my SQLite file. So that's a nice trick to be aware of there too. Let's zoom out here. How many folks have used SQL a lot? Fewer hands. I see like 1 or 2 hands. Cool. There's another way of using SQL glot without even using a database. You could just use like native Python objects and define your preconditions that way, the test data that you need for like a table. And I already mentioned some of these caveats. So transpolation's neat, but maybe you really need Postgres. So we're going to cover some techniques. And when I say Postgres, it might be MySQL or T-SQL or whatever dialect you need. So we're still in this bucket of testing transformation logic. One other trick, you're going to kind of see like testing infrastructure from the ground up, because my understanding is like there's some tools out there, whether it's DBT or SQL Mesh that kind of do this under the hood. But it's not too hard to hand roll some of this. So what we're going to do here, the technique, the substitution strategy is going to be, let's say we had that SQL code here on the bottom. That was the SQL we're trying to test. What we're going for is we're going to basically insert that SQL into a common table expression where so you see the with block, with orders, and then instead of the insert intos, we're going to do a bunch of select statements to kind of seed that common table expression. And so now when we do select from orders, we don't need to reference an actual physical table, right? We can just reference that virtual table is probably like not the technical term, but the named reference in the CTE. So that's what we're going to do. But you don't want to write this or do this by hand. It's a little hacky to be like modifying the SQL you're running, but it's cool. You can use the advantage of this approach that's nice is you can actually run this kind of code on your production database and not query. Don't run it on prod, but you wouldn't be actually hitting the orders table, and you're running on a real database, real Postgres or whatever you're using. So that's kind of neat too, and it cleans up after itself. So. But the question is, how do we get to that SQL for our test runner? So let's work on that. How many folks are familiar with the pipe operator with dictionary merging in Python? Cool, couple hands, about half or a quarter of the room, or a third. Cool. I'm going to introduce the syntax a little bit, but there's a kind of important reason we're using it, though, too, that's useful for testing SQL specifically. But what we're doing is we're starting with like a default row, basically. We've got a function called order that's going to take some overrides. So there's just going to be like 1 or 2 columns that we care about changing for our test. And so when you do the pipe, you're going to override just the keys that you want. So when we set up our data, you see we've got like region, north, amount, 200. So what that's going to do is when we call the order function, it's going to take the default order with all of our keys and just override those 2 attributes, those 2 keys. And the advantage of this with a lot of test setup is it can lead to much less redundancy. If you've got like a 50-column table and there's really only 2 fields that are relevant to the thing you're trying to test, you probably don't want to like have a 50-field dictionary just setting up the test and someone reading it is like, what's the difference? There's 100 of these tests. I don't know which one's like, what's the important field that's different? So using that kind of pipe trick kind of is nice for readability. It lets you like highlight the part that's important for the test. How many folks have used like Django, ORM, and I think it's Factory Boy, right? Or cool, couple hands. So if you're using an object relational mapper, you get some tools like this for free, but I'm hoping part of what motivated you to come to this talk is sometimes maybe you're in a context where you don't have an ORM or you don't want one or whatnot. So what the rest of this code is doing is we're basically preparing this list of dictionaries. We're passing it in. I'm going to hand wave what those 2 functions are doing, create mock CTE, merge CTE with SQL. The slide deck at the end will have a few more code snippets, but basically it's that earlier slide I showed with like with the with block and then the query we're trying to test. And it's just like doing some string parsing basically to kind of to merge those into SQL that we could use just for our test. And if that sounds weird, I'm going to show a few more techniques, so you don't need to use this one. Cool. So yeah, I already covered this part, but the default row pattern and overriding. I didn't really talk through the star, but just for folks kind of coming into new to Python, that's gonna, when you take a dictionary, you pass it into a function and you star tuple unpacking, like it's gonna take a dictionary and convert it to these named keyword arguments with the values from that dict. How many folks use PyTest parameterize? Cool, couple hands in the room, third, yeah. So often if you're trying to run, like use the same test, but just your inputs are changing, you might want to like kind of factor that out. It takes a little getting used to but I think it's a high ROI feature of PyTest to kind of get familiar with. But basically, like if I just want to change, if I wanted to write this test 3 times, but only change the region, the list of amounts, and the expected total, rather than have 3 separate tests, I'm just going to pass in this tuple with those values. And then it's a little bit of PyTest magic, but somehow this string becomes named params in there that you can pass into your test function. And when you invoke PyTest, you're going to get 3 separate tests. And that way also you will see, like, if only one of them out of the 3 failed, they'll all execute, but you won't like fail on just the first one. It's kind of context dependent when this is more readable versus not. Like here, I might argue like maybe it's okay to repeat yourself sometimes with test code for readability, but that's your call. The warning here is just like if the SQL you're trying to test is using common table expressions and then you're trying to like inject it into a common table expression, the parsing gets a little weirder. There's frameworks that deal with this for you, but it could be a fun exercise. I think like a lot of people, it's pretty accessible. I did it. It's not too hard, but it's annoying. But if you find yourself doing it, maybe like consider reaching for an off-the-shelf kind of tool. Cool. So that's got us covered on testing transformation logic. Now I mentioned like, what if I want to test against a real database? And then what do I mean by real database? Like, is it prod? Is it somewhere else? One of the techniques I'll show is like, let's use Postgres as an example, but it could be MySQL or Trino or whatever. You can run these in a container on your machine. How many folks use Docker by chance? Cool, a lot of hands. So you can use vanilla Docker Compose. You can use, there's a few packages out there. I have less experience with test containers. PyTest Docker tools is neat, but it kind of lets you pass around like Docker stuff as fixtures, like, and you stay in Python. In Python, personally, I use Docker Compose the most. Like, I don't mind typing Docker Compose up, and you have that step, and then your test code is going to assume the database is running. But maybe you don't like Docker stuff, and maybe you have Postgres like running on hosts. You use the Postgres app or whatever, or whatever the database is. You'll see like PyTest PostgreSQL will support the local the PG option. If the Docker stuff is intimidating at all, I just say like some of the AI tools can help you with it, but also just you don't need to be a huge like YAML engineer to do it. There's not too just these few lines of incantations get you like a working database on your machine. And when you normally connect to a database, so prod database, staging, whatever, you're passing a URL, your creds, the port, right? Here it's just going to be your server is going to be localhost, port, whatever you configure here, how you've mapped from your container, and then some fake credentials. And you can connect to that URL. And then when we go back into PyTest land, this is just one way of doing it. But like I said, you would set up a connection to localhost as your URL, and then now with our fixture, this is a resource we can now pass around to other tests that need a Postgres connection. So you see, before the yield, that's our setup. We're initializing the connection. In our test code, you'll see at the very bottom there how it takes a parameter, Postgres con. I kind of like to think of it as like whatever's coming out of the yield. That's what the Postgres con with tables is going to receive. And then after that test runs, then the connection's going to close. That's going to be the cleanup. And hopefully the takeaway here is that not a lot changed in our test code, so you can kind of try all these approaches with not too much effort as far as our like insert our seed data, run our SQL, and assert the results on some expected value, because Postgres is compliant with the Python database API. So, and how many folks have you ever felt like coupled to a particular database implementation in the way you write your code? Okay, see a hand, yeah. Some, and the constraints are different. If your rules are I can't change the code, but I need to write a test for it, then like life might be a little harder. But if you can change your code, then like you might start thinking about different ways to design like your SQL runner and that kind of thing, right? And one other tricky thing with SQL is isolation. So often you don't want like tests to step on each other. So like if I have one test that's inserting stuff or creating tables it has some precondition that involves like creating stuff, and I have another test running in parallel, or if my first test doesn't clean up after itself, and the subsequent test has some assumptions about the data, you're going to get what's called like a flaky test or some kind of collision or lack of isolation. So just to be mindful, whether you do it from scratch like this or some of the ORM tools have this too, you can kind of toggle whether you care about transactions or not. This comes up in Django ORM. You've got like a standard test case, transaction test case, but so that's just one thing to be aware of too. Another thing sometimes we want to test is we might be reading from tables, but the schema, like we don't own them, meaning that it might be another team that runs and owns the create table statements. And so if I change my SQL code or my Python code and it makes assumptions about the schema, I might care if the schema changes. Now, if you're in ORM land, and like, I'm going to use Django as an example, you have this notion of migrations, right? To keep your application code in sync with the state of the database. And this wouldn't happen as much, but you don't always manage the table. So sometimes you might care about the schema. So one tool, so you might want to basically make an assumption. This is kind of a change detector test. Some people don't like that. Like it's like, but like in this case, you care about the change. So the change detector would be kind of useful. Another thing related to schema and types is just like if you have a need to make sure that the types of the data when you put them in from Python and then insert them, and then when you read them back, they should like nothing weird happened on the way there. So you might want to do a round trip test. And then one really cool feature. Now I'm mostly in Django land, but with what's this SQL Alchemy, actually, I believe it could reflect from a Django database. How many folks use SQL Alchemy? Cool. Looks like half or more. If you're not familiar, there's also this cool feature called metadata reflection. So we mentioned that one of the tricky things with testing SQL is reproducing the state of the database, like the schema. Do you have to manually write, like create table statements or that someone else already did in a repo you don't own or something like that? And the answer is usually no. So you can basically connect to like a remote database. Let's call it staging, and then you do metadata reflect, and you can actually take that schema and reflect it into like a SQLite a local database or your local Postgres to kind of seed your local schema. And this is about SQL, so I won't spend too much time on ORMs, but besides just saying that they kind of handle a lot of this, but they're not always available to us. Now, I kind of showed things a little bit more from the ground up approach. I just wanted to call out there are tools out there that do this. Frankly, I've tried them like before, but not like, I just don't have, like, I don't use them at work personally, but I did want to offer some pointers to them. So basically what they do, so in this case, it's a similar idea. Like we have some input data rows that we want to seed our orders table with. The model would be like the SQL logic we want to run, and then we have some expected output. And basically you're writing your unit test as YAML in this case. I mix up DBT and SQL mesh, but sometimes you can even pass in a CSV rather than YAML or in other formats. One thing that's confusing when you look into that is like you might have heard of DBT data tests, and that's a different kind of test. DBT has this like, those are more like assertions on like, are the values in my column unique? Are they like, or non-null, and et cetera, et cetera. So just a heads up that there's a little bit of the, I got thrown off by that at first. And SQL Mesh also has a lot of similar tooling too. So that might be of interest to look into. But you have like what you need to like hand roll some of that. I'm going to, thought I had to skip this section for time, but I will. A few non-testing questions. I want to leave some time for questions. Are a few non-testing topics, but still related to code quality that I feel like a lot of folks using SQL might not be aware of. are just like formatters and linters. So just like for Python, we've got those available for SQL as well. And how many folks are familiar with pre-commit hooks? Git, so, okay, cool. This is another one of those like really high ROI, like cryptic incantation things when you're learning it at first, but it is really like a very super repeatable tool to have in your belt. So basically the idea is I have something I want to do before I commit. And that way you don't need to think about like manually invoking your formatter or that kind of thing. It just kind of happens and catches it for you. And then, again, I don't want to teach a particular like CI/CD workflow, but just as a concrete example, if you want to both run your tests or run some formatters, but also since you don't control whether your colleagues do it or vice versa, you want this to run in a remote environment, like when you push to GitHub or Bitbucket or whatever. The tool you might want to reach for is CI/CD, a workflow such as this. And basically, you can define some YAML to kind of do like what we were doing in Docker earlier. Like you get access to Postgres in a remote environment off your machine, and that way you're not only relying on people running tests locally. Now, a bit out of scope for the talk was hopefully no one came to the talk looking for data quality testing, but that's like, there's a whole another suite of tools for that. You might have heard of some tools like Grid Expectations, Soda Core. You probably hand-rolled your own like data quality frameworks or little modules and libraries. But that I would consider like a separate topic from unit testing. That's also what makes testing kind of tricky. Is like, what do we care about here? Is it like the data, or is it the just like this piece of the SQL transformation and prove that it works? So here's a little bit of what we covered today. And here's a few exercises if you're wondering, like, what can I do with this? What should I do when I go to work next week? Or, yeah, I'd say like pick some SQL. First, think of like what are SQL's file. Can you think of any SQL that's been causing you problems though too? Because again, you don't just like apply this to every SQL statement you find out there, but yeah, that can help kind of prioritize where to start. And just a little bit of plug. So I mentioned earlier, I work at a company called Turquoise Health. This QR code is going to be on the next slide too. We are hiring. And I put the slides on my website, so you're welcome to see it there. And would love to hear what you thought about the talk.
Thank you, Paul. I especially appreciated the variety of options we got here for different types of use cases and the checks to make sure we were all following along. As Paul mentioned, he will be taking some questions. If you have a question for Paul, please come to the center aisle, and there are 2 microphones. Your choice of microphone, please stand at one of those microphones to ask a question so we can make sure those are recorded. Let's give one more round of applause to Paul while first questioners are getting up. Thank you. I see a couple people walking towards microphones, so I'm going to give it a minute here.
Hello. Thank you so much for the talk. I really appreciate it. I'm working as a data person at JP Morgan Chase, and one of the things that I am trying to do is ensure that I have deterministic replayability for my tests between test runs. My question is, you mentioned in PyTest there was a fixture for setting up a database connection, running something, and then there was cleanup at the end. My question is the cleanup something that's supposed to be done in the fixture itself, or is that supposed to happen within the body of the test?
Usually in the fixture. I did show an example earlier. Or do I have to repeat the question just really quick for the recording?
No.
Okay. Cool. A more common pattern is probably in the fixture itself. So before the yield and after the yield, and that's kind of the idea there. I might have confused things too when I said like your arrange, act, assert. Sometimes a lot of your arrange step is already done for you because once you bring in the fixture, like that might have already handled a lot of the arrange step for you. So it kind of depends. It's a bit of a judgment call too on how much how dry, like do not repeat yourself you want to be. I've seen tests that go a little too overboard with like factoring stuff out where you're like scattered looking all over the place. But for something like a database connection, like that kind of thing, that's totally reasonable to have in a fixture somewhere else.
All right, thank you.
Yeah. Did you you haven't shown an example of how to test like a stored procedure or function, have you?
No, I haven't, but that should work like with the if you're running real Postgres. But I actually don't have experience actually having done it.
Okay.
But let me come. I'm going to publish the slides. I'm going to see if I could find one or add one to the appendix.
Do you have tips for speeding up the like spin up and spin down of like a real Postgres database when you're running tests so they run quickly?
Yeah. So there's this notion of, I don't know if this is answering your exact question. I mean, there's you can play around with the scope. Like if you're not talking about a single test, I guess you could reuse like a single fixture across an entire test session. I'm trying to think of cases that slow things down. What is it with I can't come up with off the top of my head, but sometimes when your tests slow down, I know in Django, I think it was the not setup test data or setup class test data or something like that, where you end up like reseeding per test method rather than for the whole class. But that might be for ORM land. But those are the first few things that come to mind.